Composite functions. So here's an example, fg of x. That's how they look. Now what this means is that we need to substitute the function g of x in place of the x in the f of x function. Now typically, 9 times out of 10, fg of x will not be the same as gf of x. It matters which way round you do it in most cases. Should you come across this notation, f squared x, then that actually means ff(x). So in other words, you're going to substitute the function of x into the function of x. So we're going to look at how we deal with these composite functions, and the first method I'm going to show you can use if you're actually given a value of x. So for example, here we have f of x equals 2x squared minus 1, g of x equals x minus 5, and they're asking us to find fg of 2. So we've got that x value there. So the first thing we're going to do is evaluate g of 2, which would give us 2 minus 5, which is minus 3. Then we're going to substitute g2 into f of x. So that gives us fg2 equals 2 brackets minus 3 squared minus 1, which is 2 times 9 minus 1, which is 17. So method 2 is for when you're not given a value of x. So in this example, f of x is 2x squared minus 1 and g of x is x minus 5, and we need to find fg of x. So we're going to replace the x in the f of x function with g of x. So that gives us fg of x equals 2 brackets, put in the g of x, x minus 5 squared minus 1. Now we just need to expand and simplify. So expanding the brackets there, we get 2x squared minus 10x plus 25 and the minus 1 on the end. And if we tidy that up, we get 2x squared minus 20x plus 49. So just to show that gf of x is usually different to fg of x, let's do that. So this means putting f of x into g of x. So instead of the x in the gx function, we're going to replace that with 2x squared minus 1. And then if we expand the brackets, that leads us to 2x squared minus 6. So it's quite obvious that those are not the same.